Hi everyone. Today we are going to discuss a problem on CSIR UGC NET Mathematical Science June 2021 LPP paper. Consider the LPP. Minimize 14x plus 9y plus 6z subject to the constraint 2x plus y plus z greater than or equal to 8 and 3x plus 2y plus z greater than or equal to 10. X greater than or equal to 0, y greater than or equal to 0 and z greater than or equal to 0. What is the optimum value of the objective function? First option 52, second option 48, third option 15 and fourth option 56. Let it minimize ZW is equal to 14x plus 9y plus 6z and is subject to the constraint 2x plus y plus z greater than or equal to 8 and 3x plus 2y plus z greater than or equal to 10. First, convert this question in matrix form. That is minimize W is equal to the raw matrix 14, 9, 6 and column matrix X, Y, Z. Similar way, subject to the 2 cross 3 matrix 2, 1, 1, 3, 2, 1 and the column matrix XYZ is greater than or equal to the column matrix 8 and 10. We already know that the minimum value of W is equal to B transpose Y and A transpose into Y is greater than or equal to C and Y greater than or equal to 0 if and only if the maximum value of Z is equal to C transpose X and AX greater than or equal AX less than or equal to B X greater than or equal to 0. That is the minimum problem. The minimum of W is equal to dual of maximum. We already know the minimum W of the primal problem is if and only if the maximum value of the dual problem. So, the corresponding dual problem maximum Z is equal to the raw matrix 8, 10 and the column matrix X1 and X2 subject to the constraint A transpose that is equal to 2, 1, 1, 3, 2, 1 into the column the raw matrix X1 X2 is less than or equal to the column matrix 14 9 6 X1 greater than or equal to 0 X2 greater than or equal to 0. That is minimize Z is equal to maximize Z is equal to 8x1 plus 10x2 subject to constraint 2x1 plus 3x2 is less than or equal to 14, x1 plus 2x2 less than or equal to 9 and x1 plus x2 less than or equal to 6. x1 greater than or equal to 0, x2 greater than or equal to 0. This problem easily solved by graphical method. First the x intersect point and y intersect point find out the each constraint. That is 2x1 plus 3x2 is equal to 14. Put the x1 is equal to 0. Then we get the x2 is equal to 14 by 3. And x2 is equal to 0. Similarly, that implies we get the x1 is equal to 7. And the second constraint, the y intersect point and x intersect point are find out. That is x1 plus 2x2 is equal to 9. Put x1 is equal to 0, then we get x2 is equal to 9 by 2, and x2 is equal to 0, then we get x1 is equal to 9. Similarly, the third constraint x1 plus x2 is equal to 6, that is equal to x1 is equal to 0, then we get x2 is equal to 6, and x2 is equal to 0, then we get x1 is equal to 6. This is the each constraint x1 intersect point and x2 intersect point. So by the graph, this is the graph of our constraint. First graph is equal to x1 plus x2 is equal to 6 is the red line, and 2x1 plus 3x2 is equal to 14 is the second one, and the third one x1 plus 2x2 is equal to 9 is the black, and this is the region, and the corner point A, B, C, D and E are identified. First of all, we already know A point and B point and E point, and find out the point C and D. So C and D are intersecting line, and find out the value of x1 and x2. So first case, the point C, 2x1 plus 3x2 is equal to 14, and x1 plus x2 is equal to 6. First of all, the equation number 2 into 2, we get 2x1 plus 2x2 is equal to 12, and 3 minus 1, equation 3, and subtract the equation number 1, we get x2 is equal to 2. Substituting this equation 2, then we get x1 is equal to 2 is x1 plus 2 is equal to 6. That implies x1 is equal to 4. Therefore, the point C is equal to 4, 2. Similarly, find out the point of D. Therefore, the point D intersecting line x1 plus 2x2 is equal to 9, and x1 plus 2x1 plus 3x2 is equal to 14. That is equation number 4 and equation number 5. 5 into 2, then we get 2x1 plus 4x2 is equal to 18. Subtract the equation number 6 minus 4, then we get x2 is equal to 4. Substituting this 4 in 5, equation number 5, then we get x1 is equal to 9 minus 8, that is equal to 1. Therefore, the point D equal to 1, 4. Therefore, all the points are identified. First of all, A equal to 0, 0, and B is the 6, 0, and C is the 4, 2, and D is equal to 1, 4, and E is equal to 0, 9 by 2. Next, the table, first column, the point, and the second column is the Z value. Z is equal to 8x1 plus 10x2. Then A point, the value of Z is equal to 0, and the B point is 6, 0, that's equal to 1480 Z, and C is equal to Z 4, 2. Then we get Z is equal to 52. Similarly, D is equal to 1, 4, then we get Z is equal to 1480, and E is equal to 0, 9 by 2, then we get Z is equal to 45. Therefore, the maximum value of Z is equal to 52 at the point C is equal to C4, 2. Therefore, the given problem, minimum value of dual problem, therefore the right answer is equal to option number 1, that is equal to 52. Thank you.